Hi, Abhinav. How are you doing?
I'm good. How are you?
Very good, very good. Abhinav, today, what do you want to do?
Like more practice on graphing rational functions.
Graphing rational functions. Okay, we'll do that. Can you please introduce yourself?
So I'm Abhinav. I'm in grade 8 at Community House Middle School, and I'm in Math 2 right now.
Grade 8 and doing math 2, which is, I think, grade 10 level, right?
Yeah.
What kind of marks are you getting?
Yeah, I'm getting pretty good, 90 and above.
90 and above in grade 10 for a
Yeah.
grade 8 student is really remarkable. I'm proud of you, Abhinav. And that is why I'm actually teaching you rational functions now, which is a grade 11 and grade 12 course. Okay. So I think with that you'll be way ahead of your class fellows in grade 10. So we'll continue from where we left. Let me just open up a whiteboard. Whiteboard. And before we go there, let me also show you what I've made ready for you.
Okay.
That is kind of important, right? So let me just share my screen and tell you the worksheet which you are supposed to do after we end this class today. Okay.
Okay.
Can you see the screen?
Yeah.
So these are the equations which you have to graph today after our lesson. You get the idea. So
Yeah.
I have 12 questions here, which are all the rational functions where you have, degree 2, 3 in the numerator or in denominator, as you can see. They will test your factoring skills and complete understanding of graphing rational functions. Is that okay?
Yeah.
The graphs of these functions may look like something like this. Do you see that?
Yeah.
With all the parameters. So it may look like this. So they are not easy. And a lot of parameters which we calculate, you need to work on these today in our lesson and master these techniques. You get the idea, right? So you have to
Yeah.
master these techniques. You see the graph going like this. We will talk about oblique asymptotes also today, apart from horizontal and vertical asymptotes. Is that clear to you?
Yeah.
Perfect. So uh, let me now share with you a whiteboard from where we are going to begin. So let me just share with you a whiteboard and we'll get into the concepts of rational functions and see how do we graph them. First thing, can you tell me what is a rational function?
It's basically like a quotient of polynomials.
Perfect. So it is, as you are saying, good language, quotient of polynomials. What do you really mean by that?
It's like one polynomial over the other.
So let's say a numerator is a polynomial and a denominator is also a polynomial. Any restrictions?
No.
Denominator cannot be zero.
Oh, yeah, no, I can't remember. Yeah.
That leads to restrictions. You get the idea. So this is restrictions. Is it okay?
Yeah.
Perfect. Now restrictions are very important when we graph our functions because at these points, the domain, that value is missing wherever the denominator is zero. Now these restrictions can lead to two things. One, vertical asymptote. And the other is a hole. So we'll talk about both these things. When do you get a vertical asymptote and when do you get a hole? Perfect. So we'll actually begin from here. You've given me a very good starting point. Normally, I would not have started from here. So let me just share with you clear all and take up examples where we'll talk about restrictions. So let's say my function is, I'm starting with a of x. We'll say ABC will be our functions. Simple as that. I have a function which is 1 over 2x minus 6. Now, can you tell me the restrictions on this function? In this
Okay.
case, x is not equal to what?
3.
X is not equal to 3 since that makes the denominator 0. And how did you find it? You equated 2x minus 6 to 0 and you said, well, 2x is equals to 6, x is equals to 6 over 2, and therefore x is equals to 3. 3 will make the denominator 0. That becomes our restriction. So that is Abhinav, grade 8 student, learning grade 12 rational functions. And you're quick, you're fast at it. Good job. Now, will this restriction, how will it look like on a graph? Let's see the graph of it now. Is that okay?
Yeah.
So we already know that we have a restriction. So I have a very approximate drawings on the graph, but they are fairly accurate. Accurate to give you 100% marks in the test. You understand what I'm trying to say?
Yeah.
Okay. So this restriction, x is not equal to 3, leads to what? Can you tell me?
The vertical asymptote.
Vertical asymptote. So we have a vertical asymptote at which point? At x equals to 3. So that becomes the equation of vertical asymptote. You get the idea?
Yeah.
So this is your 3 on the scale. So let me just mark 1 and 2 like this. So do you see how approximately I have drawn my diagram, but it's fairly accurate. Since this point here represents 3 for me, where we have a vertical asymptote. Now, for the given equation, can you find the x-intercept? Tell me, what is the x-intercept?
1.
No x-intercept. This is a very tricky question. X-intercept means y equals to 0, right?
Yeah.
What I'm trying to say here is that means y equals to 0 means a of x equals to 0. Now, it can never be 0 because the numerator is 1. Do you see that? Numerator is a constant, right? So here, numerator is constant. It cannot be 1. Is it okay? It cannot be 0, right? So there is no x-intercept. Do you understand?
Yeah.
So now looking at the equation, you at least know there is no x-intercept whatsoever. But we also know that the function has only one restriction, which is x equals to 3. Then how come that y value will never be 0? So that is something which we have to think about, correct?
Yeah.
Okay, we'll come back to this. But now let us look into the y-intercept. Tell me, what is y-intercept?
Okay. I got 1 over minus 6.
Perfect. So y-intercept is 1 over minus 6, as Abhinav is saying. So minus 1 over 6 is my y-intercept. Is that clear to you?
Yeah.
So we know at least 2 points now. One, we know where the vertical asymptote is and where the y-intercept is, correct? Now,
Yeah.
what is the nature of this graph? Can you tell me? More or less, it is like a reciprocal function, right?
Yeah.
So let's look into this. Parent function is 1 over x, correct? So the nature of the graph basically is kind of like this, right? Something like this. I should not draw a vertical line, that will confuse you, but the graph is kind of like this. Is that clear to you?
Yeah.
Like 1 over x. So we have a good idea that our graph is going to be like this. Does it make sense?
Yeah.
So that is the approximate graph. To make it more accurate, what can you do? Well, to make it more accurate, you can have some more points, right? We'll talk about asymptotes later, but let me just put some points, easy points to work with. You said x equals to 0. You can work with x equals to positive and negative values. Positive and negative, like you want some points on this side and on that side, correct? So put and find the value of a equals to, let us say 2, and a equals to 4. What do you get? Substitute 2 and 4 and get your answer.
Okay. Yeah, I got 1 minus 1 over 2 and 1 over 2.
Correct. So when you're on this side, when a is 2, you get minus 1 over 2. Do you see that, this point? And on the other hand, you got a point which was at 4.5. You see the symmetry about this vertex point?
Yeah.
So, well, those are your points on the curve of this particular function ax. Is that clear to you?
Yeah.
Likewise, you could also find more points. Now, let us summarize our learnings and see how do we try to sketch a graph of this kind of a function. So we have this function a of x equals to 1 over 2x minus 6. So what did we do? We began with the vertical asymptote and we say, well, vertical asymptote is when 2x minus 6 equals to 0. And that gave us the value of x as equal to 3, right? Then we found what is the value of the function when a is 0. So at a equals to 0, what I'm trying to do here is trying to get some values. Is that okay? So I could write something like this, that let me make a table from here. Okay, let me extend. So for different x values, I'm trying to find what a of x is. So for x equals to 0, I got a value which is equals to minus 1 over 6. And that is my y-intercept. Is that clear?
Yeah.
Now, so I could actually have 3. Since 3 is my vertical asymptote, it's good idea to get values like 1, 2, 3, 4, and 5. Is that okay?
Yeah.
So you can calculate these points. Now, let me sketch the graph. After calculating one more thing, and that is, we discovered that no x-intercept, right?
Yeah.
And domain is what? Domain is x belongs to real values, right? But we know x is not equal to 3 because 3 is your vertical asymptote, right?
Yeah.
So we know here that x is not equal to 3, but all other values are valid. So what happens when x is very large positive value, and what happens when x is very large negative value? This is what we have to check. Now that is called end behavior. Is it okay?
Yeah.
Now let's figure this out. So we have a of x equals to 1 over 2x minus 6. Now if x approaches very large value, what will happen to this? Denominator is a very large number, let's say 1,000, 10,000, 100,000. Then it is approaching 0, correct?
Yeah.
When it is a positive number, it is positive. It approaches from positive side, right? Because the reciprocal of a positive number is positive. What happens to a of x equals to 1 over 2x minus 6 when x approaches negative infinity? It is again approaching 0. However, this time from a negative side. Does it make sense to you?
Yeah.
Correct. We are going to put all this information on our graph and then finally going to draw this graph. Is that okay?
Yeah.
Let me clear this and get to the graph now. So we're talking about one function a of x equals to 1 over 2x minus 6. And now the graph is very simple, which we kind of drew in the beginning also, but we're taking time to understand the concepts, right?
Yeah.
So key concepts. These will help us to draw complicated graphs, okay? So we know there is a vertical asymptote and we know there is a horizontal asymptote. Abhinav, what is the equation of vertical asymptote?
X equals 3.
What is the equation of the horizontal asymptote?
There is no horizontal asymptote.
There is, y equals to 0. How did we figure this out? When x approaches positive infinity, y approaches 0, correct? When x approaches negative infinity, y approaches again 0. We did that just now, correct?
Yeah.
We also noticed when it approaches positive infinity, it approaches 0 from the positive side. That means the graph is kind of going like this in this side. Do you see that?
Yeah.
But when it approaches negative infinity, it approaches 0 from the negative side, kind of like this. Do you see that?
Yeah.
So that is what we mean. When it approaches positive or negative infinity, y approaches a fixed value, that is 0. Since y approaches 0, we have a horizontal asymptote.
Okay.
Whose equation is y equals to 0? Have you understood this equation now?
Yeah.
That is the concept of horizontal asymptote, which I wanted to teach you before getting into the final graph. Now, can you summarize what is a horizontal asymptote and how will you find a horizontal asymptote?
So basically, so when x approaches infinity, you find what the y value equals, and it's 0 to the positive side. And then you find what y equals when x approaches negative infinity, and it's 0 from the negative side. So then that means the horizontal asymptote is equal to 0.
Perfect. Minor correction, which I'd like you to note, and that is when x approaches, so let me write down the words here, right? Which you said when x approaches positive infinity, y equals to never approaches 0 from positive side. Do you see that word approaches? Y will never be equal to. Y will be very, 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 very close to 0, but never 0. You understand?
Yeah.
So if that happens, this is a real value. 0 is a real value, right? It could be any value, let's say L. In that case, we have a horizontal asymptote whose equation is y equals to L. In this case, L is 0. So the equation is y equals to 0. Is that clear to you?
Yeah.
Perfect. So we have understood all the components of sketching the type of function. Now let me generalize this. Clear. So I have actually taught you how do we sketch a function y equals to any constant over ax minus b. Do you understand this?
Yeah.
Any constant, it could be any value. In that case, now tell me, what is the vertical asymptote? We will assume all of them to be positive values. So we'll begin now for a general value. So what is the vertical asymptote? Tell me.
X equals 3.
No, for this function, k divided by ax minus b.
B over A.
Yes, b over a. So we say that we have a vertical asymptote at x equals to b over a. Do you see that general equation?
Yeah.
It could be a 1, 2, 3, any number, doesn't matter. One. Second, what is the value of this function? So it has a horizontal asymptote. Can you tell me what is the horizontal asymptote?
Uh,
Again, y equals to 0, because if I put x as a very large number, since denominator is a very large number, 1 divided by infinity is 0.
yeah.
Therefore, y equals to 0 will be my horizontal asymptote. Is that clear to you?
Yeah.
We are assuming that k, a, and b are all greater than 0. Is that okay? All positive. Is it okay?
Yeah.
Now, in that case, if I plug in a value of x, which is greater than b over a, right? So let me rewrite this function, k, and if I take away a common, then I get x minus b over a. Do you see this?
Yeah.
Correct? So that is why you said that x cannot be equal to b over a. Now, if I have a value on the right side, if I have x which is greater than b over a, then we know that y is greater than 0. Is it okay? Because
Yeah.
positive. So therefore, looking into this, we know that the graph of this particular function on the left side, on the right side will be like this. Is that clear to you?
Yeah.
And on this other side, it is going to be like this. Is that clear to you?
Yeah.
Where this particular point which is the y-intercept is going to be what? Just substitute x equals to 0. So this point will be k over b with the negative side. Am I right?
Yeah.
Do you see? Once you understand the concept, you can now sketch hundreds of equations with this particular screen seen there. Is that okay? The only
Yeah.
thing which you need to do for getting some more points is make a table of values. Is that okay?
Yeah.
So in this table of values, just plug in a few points of x and find y. Is it okay?
Yeah.
You need 4 of them. So put those 4 points and then you get the other points on the graph and you sketch. Perfect graph. Is that okay?
Yeah.
No difficulty. Just let's review. Y equals to, let's say 5. Now we have this function as, let me say 3x minus 12. Correct? Can you quickly tell me how will I sketch this graph?
Okay. So you first find the vertical asymptote, which is 4. So x can't equal 4.
Very good. Next step.
And then you find the horizontal asymptote, which is y equals 0.
And sketch it on the graph with dotted lines as just as I'm showing. Red is a better color to sketch. Is that okay?
Yeah.
Next.
And then you find the y-intercept by replacing x with 0.
Y equals to 5 over 12 with a negative sign. And then you sketch it. Do you see that?
Yeah.
Does it make sense?
Yeah.
Done. And if on this you have more values, do you understand? You will get the other points, which will be kind of like this. Is that okay?
Yeah.
And you get 100% marks. This is what you have to do when you have a rational function which has a constant on the numerator. Is that okay?
Yeah.
And a linear function in the denominator. Okay. Now we will look into another function which is slight modification on this. So let me clear the screen and write down the second equation. We have now b type of a function. B of x is equals to, let's say, we have 1 over. I mean, keeping it simple, just as we did last time. Okay, 2x minus 6 plus, let us say 3. How will this graph be different from the earlier graph? Tell me this now.
I think it moves right 3 units.
That is because of this, right? Let me change this. Let me change this equation because that is going to confuse you, right? So 2x minus, sorry. Okay. 2x minus 6 plus 5. Okay. Now you tell me. What is the effect of adding 5 here? Transformations, please.
Okay, it moves right 5 units.
Vertical translation. Vertical translation. Move 5 units up. You see that?
Yeah.
Move 5 units up. So earlier graph, let me sketch the earlier graph, right? So earlier graph was kind of like this. I mean, I'm just sketching one approximately. Earlier graph, this graph is for 1 over 2x minus 6, which we just now did, right?
Yeah.
Now the new graph, I have to just move it 5 units up. So I have a horizontal asymptote here. Do you see that?
Yeah.
Same vertical asymptote. So my graph now is like this. Maybe this. Are you sure it's okay? This is what it is. And to get your points, just plug in some points and get your values. Does it make sense to you?
Yeah.
You got it, right?
Yeah.
So that is how you have to do. So let me now summarize this in a very beautiful way y equals to, let's say a constant k, right? Ax minus b. We know that x is not equal to, okay, I should add more components to it. We are doing, okay, let me just erase this. Let me use another way, right? Y equals to, uh, uh, H and K are normally used for translations. So let me say D on the top, AX minus B plus K. Is that okay now?
Yeah.
Now, in this case, we know that A is not equals to B over, sorry, X is not equal to B over A. Okay. X is not equal to B over A, correct?
Yeah.
And we also know here, what is the vertical asymptote? Vertical asymptote is X equals to B over A. Horizontal asymptote is what? Tell me now.
K.
Is K. Y equals to K. Excellent answer. Perfect. Because that has moved vertically by 5 units. You have nailed it. And so we do have a graph here. And let me sketch the graph directly, Abhinav, for you, because it just gave me the exact answer which I was looking for. So this is Y equals to K, the horizontal asymptote. And now we have a vertical asymptote, which is X equals to B over A. And once I get few points on this, I will actually graph my function kind of like this. Is that okay?
Yeah.
Good job. So we already have a function here. Now, can I ask you one question?
Yeah.
I want to find the equation. Let us say this point is, let us say, let me give you some points now. Let me say that this point is 5. Let me say 4, okay. This is 4, okay. And this point is, let us say 1. Is okay, y-intercept?
Yeah.
Can you tell me the equation of this function?
Okay.
Yes. Find equation.
Okay.
So this time what we have done, we are doing the reverse. We already have a graph, and from the graph we will find the equation. Okay.
Yeah.
Tell me. So keep telling me. So we know K is equal to what? From the K is equal to what in this case? Tell me.
4.
4. And now y-intercept is 1. How will this help you?
You can replace Y with 1.
And yeah, and then figure this out. But at this point, X is 0, right? So at X
Yeah.
equals to 0, Y equals to 1. So let's put this here, right? So we have in this equation, if I put, I get what? I get 1 equals to D over X is 0, so 0 minus B. Do you see that?
Yeah.
So I get a value which is 1 is minus D over B. You see that?
Yeah.
That really means that B is equal to minus D. Is that okay?
Okay.
B is minus D. So that means if you take any value of B, negative of that is D value.
Yeah.
So that means there are many solutions. Now there are many solutions. Is that okay?
Yeah.
How? If B, let us say, is 3, then D is minus 3. If B is 1, then D is minus 1. And if B is minus 2, then D is 2. Likewise, there could be hundreds of values. They will give you almost the same graph with the given parameters. You see that.
Yeah.
So, but if I give you the x-intercept, then we will have a specific graph, correct?
Yeah.
So what we have got here is a family of graph, family of function. And what is the characteristics of this family? That they are same y-intercept. Does it make sense? Which is shown here, correct? Now, if I add a parameter to it and I say that, well, now find the graph. If I have the x-intercept, which is at 2, now tell me, x-intercept at 2, what is the equation?
Okay.
So y is 0, right? So 0 equals to d over 2a minus b. Is it okay?
Yeah.
So how will you find this equation?
You multiply by 2a minus b on both sides.
X-intercept y equals to 0. Then you get d equals to 0.
Yeah.
No, it is plus k, we forgot. Sorry. I forgot to write plus k, which is plus 4. Is it okay? Now it is okay. Yeah. Sorry. I forgot to write 4. K is 4, right?
Yeah.
Yes. So now you find the equation. So we will put on this side minus 4 and then we'll try to do it. Is it okay?
Okay.
Okay. Let's go to a fresh page now. Let me clear this. But what we're trying to say here is that we can actually find the equation of the graph easily, correct? So let's
Yeah.
see into this aspect more clearly. So how do we find the equation from graph? Okay, so let me sketch one graph. We'll start from a simpler graph. I took a very difficult question with you now. This one is simpler. So we'll do work on this. Is it okay?
Yeah.
So let me draw a better line. I'm changing the graph. This time, look here. I've reversed the end behavior. Do you see this?
Yeah.
And I'm saying that this function is y equals to, I'll write 1 over, right? 1 over ax minus b plus k. 1 over ax minus b plus k. And I'm giving you a few points here. And these points are the x and y x-intercept, which is, let us say this x-intercept is 440. Correct?
Okay.
So, but we have how many unknowns? We have 2 unknowns, right? And I have only given you 1 point, which is x-intercept. I need to give you 1 more point to find the values. Otherwise, you'll get a family of graph, correct?
Yeah.
Correct. So we know this vertical asymptote, which is there at, let us say 2. So I have given you now 2 points. I'm saying vertical asymptote is at x equals to 2. Can you find the equation? Tell me.
Okay. So the y-intercept is 4, 0. I mean, it's 0, 4. So you replace y with 4 and x with 0.
Also note that the horizontal asymptote is y equals to 0, correct?
Yeah.
So it is good to start with the horizontal asymptote. You see that?
Yeah.
That gives you what?
Uh, 4 equals 1 over minus b plus
That
0.
see, if you start with horizontal asymptote, you know k is 0, right?
Yeah.
So this implies k equals to 0. You understand? And therefore, we have this equation as 4 equals to 1 over, you are substituting the value of x as 0 1 over minus b. Do you see that? Because k is 0, right?
Yeah.
And from here, you get the value of b, which is minus 1 over 4, correct?
Yeah.
Now, how do you find the value of a?
You replace y with 0.
So you know that ax minus b is equals to 0 at x equals to 2, because that is a vertical asymptote. Is that clear to you?
Yeah.
So if you plug 2 here, you get 2a minus b equals to 0, and a is equals to b by 2, right? And since we know that b is minus 1 over 4, we now know what is the value of a, correct? So minus 1 over 4 divided by 2 will give me minus 1 over 8, correct?
Yeah.
So we have our equation, which is y equals to 1 over, the value of a is minus 1 over 8x, and the value of b is minus 1 over 4. So it is minus of minus 1 over 4, right? And the k
Yeah.
value was 0. Now we can simplify this equation, multiplying everything by 8, common denominator, right? So we get 8 over, and in the denominator, we have minus x plus 2. Is it okay?
Yeah.
So that becomes the rational function whose graph was given to us. So see, from the two critical values, one, definitely the y-intercept, the other, the asymptotes, we could find the equation from the given graph. You get the idea?
Yeah. Why did you multiply the equation by 8 though?
Common denominator. If you look into this particular equation, minus 1 over 8x and minus 1 over 4, they are fractions in the denominator, right?
Yeah.
So to make it simpler, what I will do, I will multiply the whole equation by 8 on the top, 8 by 8. You see that?
Yeah.
So 8 will cancel here, we get minus x. 8 will move this 2. 8 divided by 4 is 2, correct? And
Okay.
we
Yeah.
get our answer, which is a much simpler equation.
Okay.
Does it make sense to you?
Yeah.
I will prefer to write this in a better way, and my final answer will be y equals to, I will take negative outside as factored, 8 x minus 2. You see that?
Yeah.
This is what we will get. And now, before we end our class, let me take another example of this kind. And this time, we will do a different kind of calculation, which will be much easier for you to figure out the answer. Is that okay?
Yeah.
Have you understood this process?
Yeah.
Great. So we'll today restrict ourselves to functions which are of the rational functions of the form some constant k over ax minus b plus c. Let us see. Is it okay?
Yeah.
Now, the graph for you is coming. I want you to tell me the equation from the given conditions. This time, I'm going to take a vertical asymptote on the left-hand side. And as last time, I'm going to sketch the graph with this feature. Is it okay? And
Yeah.
I'm providing you with some values, which are, this is my value, which is half, minus half. And this is the y-intercept, which is y equals to minus 6. Okay. And you need to tell me the equation of this particular graph. How will
Wait,
you move forward? Tell me.
y equals minus 6 is the vertical asymptote, right?
Yes, sir.
Okay.
Oh, x equals to, sorry. X equals to, I wanted to write y. Y equals to 0 is a horizontal.
Okay.
X equals to minus 6. That is a vertical line. Correct. Tell me.
Okay, so first, the horizontal asymptote is 0.
Yes.
So c equals 0.
Perfect.
So you have k over ax minus b. And then the vertical asymptote is x equals minus 6. So you can put ax minus b equals 0. And you can put a as minus 6. So it's like minus 6x minus b equals 0. and you get, yeah, minus 6x minus b equals 0, minus 6x equals b, and x equals minus b over 6.
Correct.
So that means a is minus b over 6, right?
Correct. Correct.
Okay.
You have also one more parameter to work with. Minus half as the y-intercept.
Yeah, so you replace y with the 1/2, or you replace r of x with 1/2, and
Yes.
you replace x with 0.
Correct.
So you get minus 1/2 equals k over minus b,
Correct.
and that means b equals positive 1/2, right?
Yes. So what you can do at this stage is you have again a family of curves with y-intercept given to you, right? So
Yeah,
you could assume some value of k equals to 1, for example. Is it okay?
yeah,
Because what are you getting here? You are getting a family of curve. As you can clearly see, we have to work with 1, 2, 3, 4 parameters, right? We have to work with 4 parameters, and we are only given information about 3. You see that point? We are given vertical asymptote, horizontal asymptote, and y-intercept. 3 things. And we are working with 4 parameters. That means we get a equation which will have multiple solutions. So you can assume k as 1. As soon as you assume k as 1, you can now cross multiply and get the value of b, right?
yeah.
So just cross multiply and you get what?
Okay.
So
b
b equals to 2.
2. Yeah,
Once you get b equals to 2, plug it in here. We get minus 2 over 6, which is minus 1 over 3. Is it okay?
yeah,
And so you can plug it in your question and get the answer, right?
yeah.
Okay. So here is alternate approach, which you could also follow. What I will do is my function r of x, I could write this as I'm writing 1 for k. And what I'm doing here is, since I know that the vertical asymptote is at minus 6. So I know this is like a, if I factor it out, I get here x plus 6. Is that okay?
Yeah,
So I already have my one of the factors, x plus 6. And we know that if I factor this out, that 6 is minus b by a, correct?
yeah,
Okay, anyway, if you work with this equation, now you say that y-intercept, if the point is x's value is 0, then y is minus half, right?
yeah.
So I am substituting this point x as 0, y as minus half, and getting my other value.
Okay.
So that way also I can work it out. But anyway, you got the solutions from either side. Is it okay?
Yeah.
Perfect. So that is how you could actually get the equation from the graph also. Let me end today's lesson with another example. And this time what I will do, I'll write down the equation in a term ax plus b over cx plus d. So I'm getting into a rational function, which is quotient of linear polynomials, right? Do you see that? Linear polynomials?
Yeah.
Now in this question, tell me, what is the restriction?
Okay. Okay, x cannot equal minus d over c.
You are right. Now what is the x-intercept?
Uh, okay, I got the x-intercept equals minus b over a.
Oh, it was plus a. Yeah, you're right. Minus b over a. So x-intercept is minus b over a, right?
Yeah.
What is the y-intercept?
Y equals 0.
Yeah, y equals to 0 will give you what? X, sorry. What is the y? X equals to 0, sorry. Y-intercept, x equals to 0.
Okay. B over D.
Correct. Now, what is the horizontal asymptote?
Y equals to 0.
So I'll show you. Y equals to a over c will be my horizontal asymptote. Let me teach you how I get that result. Is it okay?
Okay.
So I have this equation y equals 2. Now what I'm going to do, I'm factoring x from numerator. If I factor x, what do I get? I get a plus b over x, right?
Yeah.
And in the denominator, if I factor x, I get c plus d over x, correct?
Yeah.
So this is equal to x and x cancel, a plus b over x divided by c plus d over x, correct?
Yeah.
Understood? Now,
Yeah.
if x approaches positive infinity, y approaches what?
0.
No, we know if x approaches positive infinity, then what happens to b over x? B over x approaches 0 and d over x also approaches 0, correct?
Yeah.
Dividing by large number is 0. And therefore, we know that y approaches a over c.
Okay.
Because these two terms are 0, right?
Yeah.
So we have a horizontal asymptote, which is ratio of a and c. You get the idea.
Yeah.
Do you see that? So we could have
Yes.
graph this function also. Is this all absolutely clear to you?
Yeah.
Let me clear and take a concrete example. Y equals to 2x plus 4 over, let's say, we'll take good value so that, I get a very relevant graph. 6x, okay, plus, I'm taking factors. Is it okay? 6x plus 2. Now, how will you sketch this particular graph? Let's begin by saying what is the vertical asymptote. What is the vertical asymptote?
Uh,
Okay,
minus 1/3.
wait. Let me change this equation, right? 3x plus 2. Let me rewrite, clear all.
Okay.
There were common factors, so avoiding that. Is it okay?
Yeah.
I changed my equation. Doesn't matter. Doesn't matter. Now tell me, what is the vertical asymptote?
2 over 3.
Horizontal asymptote?
2 over 3.
Also 2 over 3, because this is this ratio, right?
Yeah.
Okay. X-intercept? Y-intercept?
Okay. Okay, I got the x-intercept equals minus 2. And the y-intercept is...
So x-intercept is when y equals to 0. So what you did here, y equals to 0. So you will say 2x plus 1 equals to 0 and x is equals to minus half. Okay.
Okay.
So minus half, not minus half. Is it okay? X-intercept. And y-intercept is when x is equals to 0, substitute 0, you get minus half. You again get the same value. The way I've taken the value. So come on. Okay.
Yeah.
Perfect. So we got all these values. So now we can sketch our function. We have a vertical asymptote at 2 over 3, slightly less than 1. Horizontal asymptote also 2 over 3, right? X and y intercepts, x-intercept, y-intercept both are as, this is y equals to 2 over 3. This is x equals to 2 over 3, less than 1, that is, right? And we have x-intercepts at minus half and y-intercept also minus half, correct? So we see that the graph will look like this. Does it make sense to you?
Yeah.
Do you see we have sketched a rational function which is quotient of two linear functions using our concepts, right?
Yeah.
So that is how we could actually work with rational functions. Is this concept clear to you so far?
Yeah.
So in today's lesson, we did all the functions where we have linear functions involved in numerator, in denominator, or otherwise. So from the exercise which I shared with you, pick up the questions where you have linear functions, correct?
Okay.
And then you should be in a position to answer them all, right? Just let me just okay, so again share with you the questions which we are talking about. So from this, there are some questions which involve linear functions. For example, this, right? So all the questions which involve linear functions for you, you can look into those and sketch them. The others which involve quadratic functions, will take them later. Okay?
Okay.
Perfect. Can you now summarize today's learnings, Abhinav?
So we started graphing rational functions for like we first worked on reciprocal functions, which is 1 over linear function. We started graphing that using vertical asymptote, horizontal asymptote, x-intercepts, y-intercepts, and like a series of points. And then we started how to find the equation based on the graph. So you
Yes.
take all the different points in the asymptotes and you can plug them back in to find the different values. And then we also did that with like polynomial functions. There's two polynomials over each other. And then we found an alternate method on how to find the horizontal asymptote, which is which is like A over C, A
Yeah.
over C value.
Coefficient. You can summarize this as it is the ratio of leading coefficients in numerator and denominator, right? So A and C were leading coefficients. You see that?
Yeah.
But if you have a constant, then the coefficient is zero. So zero over anything is zero. So it is a general formula when you have linear equations involved, right? Or a constant involved. So horizontal asymptote is always y equals to the ratio of leading coefficients in such cases. Is that okay?
Yeah.
Perfect. So that's great. So we'll continue from here in the next class and we'll talk about rational functions with higher degrees. And then we will look into the oblique asymptotes. Is that okay?
Yeah.
Thanks, Sonia. All the best. Good day.
Okay. Bye.
Thank you.